Okay, so we're first going to use what is a determinant, and then we're going to get into Kramers rule. Okay, so a determinant is that. So basically, if you were thinking about the inverse formula that we just did, it's just this bottom part. Okay, so here we go. This is called the discriminant of A. So you see what I did here? I wrote down 2, -3, 4, and -2. I wrote down the variables. Okay, so we're going to go AD. So that's AD. So 2 times -2 is -4. Subtract BC. So BC looks like this, which is -12. So -4 subtract -12 actually adds a 12, and you get 8. Okay, now here's what the next step is. Find the discriminant of x. So what I'm going to do is I'm going to replace the x values with the solutions. So these are the solutions. You're going to now plug them in instead of x. So the 3 and the 10 are going to go in the x spots. And then you do the same thing. AD, so -6 minus BC, -30 is 24. Okay, and then the last one is the discriminant of y. So this means the solutions are now going to be in the y spots. So we got to put the 2 and the 4 back in for the x. Right? I want the original x back in, but the solutions replace the y. Okay, and then the discriminant is AD 20 minus 12, which is 8. Okay, so the value for x equals the discriminant of x, so 24, divided by the discriminant of our original matrix. So x equals 3. Y is the discriminant of y, so 8, divided by the discriminant of the original. So there we go. So now we know how many ways to solve matrix, right? We had like row reduction, Gauss-Jordan. Now we have this, we had inverse. Now we have a discriminant. Okay, and again on a test, what can you do? Plug those in. Check them out to see if your equations are good. Okay. Here we go. This is where it gets crazy because this is a 3 by 4. Okay, so I'm going to do 3 by 3, so just the variables. You can only do discriminants with squares, like 3 by 3, 2 by 2, 4 by 4s. You can only do discriminants with squares. Okay, I'm going to draw a separate line here, a wall separator, and I'm going to just repeat. Okay, you ready? So I have to connect 3 diagonally. So there's 1 diagonal. 2 diagonal, 3 diagonal. Okay, you are going to times. So here we go. 3 times 2, 6 times -4 is -24. -2 times -2, 4. Oh, this one you should get. 1 times 1 times 1. 3. Okay, so do you remember what we did here? On the 2 by 2, we did like the down diagonal, and then this is an up diagonal kind of thing. So we're going to do that as well. So those were the down diagonals. Now we're going to go up diagonals. So there's 1, 2, 3. Like this? Or this? This? This one? Because it doesn't, it's not even in my original. It's all outside. This was the separator wall, so I don't make any more diagonals.
So why do you do the 3, 2, and -4?
3, 2, and this one? Because it's in it's on that side of the wall. I have to connect. This is my wall. Yeah, I will never. I'll never use that triangle. Okay, so what are these? This is a 2. This is a -6. And this one is a 8. Okay, so we have to add those together. So add those up. -24 plus 4 plus 1, is that -19? And I'm going to add those up. Is that 4? Okay, so what did we do here? We did the down subtract the up, basically, right? The down diagonals subtract the up diagonals. So the down minus the up is -23. And we're going to call that discriminant A, because it was just our original matrix. Okay, so that was the dA. Okay, so now we're going to make a discriminant for a Okay, we're going to go with the x. So what does it mean when I say the x? What do you do again? Replace the x with the solutions. Okay, so the solutions go into that spot, and then this is the y, this is the z. Okay, so then you're going to repeat. If you want, you need 2 repeats, 1 repeat, 2 repeats. You can repeat the whole thing and just circle what you need to, but this is what it's always going to be, because you could see here what I did. I repeat it all, but I don't ever use those ones. So you can repeat them all, but okay, so let's go the first down diagonal, down diagonal, down diagonal. Oh boy, here we go. I'm going to go here, -8 times 9. -72. What's -2 cubed? -8. And -5. So I got -85 on all that. Okay, so here we go. Discriminant x equals the down diagonals, subtract, and now we need the up diagonals. Okay, so that's going to look like this. There's an up, up, and an up. So those three. Okay, so this one has a -4, -18, and -40. So that's -62 added together. Okay, now I know what x is. X is -23 dx divided by the original -23. So x is 1. Okay, ready? We're almost halfway there. Now we got to do the y. Okay, so write your x's, so 3, 1, 1. Those are all the x letters. And now you have to put the solutions into the y positions. So this needs to be a 9, a -5, and a -2. And then the original z's. Okay, start repeating so that you can always find a 3 diagonal. Three diagonals. Okay, I want you to try this on your own. I'm going to work too. Give me all the down diagonals added together, all the up diagonals added together. So on my downs, I got 60, -18, -2, which was all together 40. On my ups, I got a -5, a 12, and a -36, which was -29. The downs minus the ups, I got 69, so 69 divided by the original, I got a -3. Okay, so this is your arrangement, all the x coefficients, all the y coefficients, but then this time for z, the solutions replace the z's. So we're going to call this dz. Okay, give me some repeats so that you can make your 3 diagonals. Down diagonals and up diagonals. Okay, go ahead, get all the downs, all the ups, downs minus ups. The downs were -12, 10, and 9, so that added to 7. all the ups, 18, negative 15, and 4, which adds 7. So the downs minus the ups is 0. So the solution to z is 0 divided by the original, which was negative 23. Therefore, z equals 0. Okay, and again, what do you know at the end? So you have this x, y, and z solution. You can always do what? Plug in to all your equations, and you can tell if you're right or not. Okay, you can plug them in. So when you plug in a 1, a negative 3, and a 0, that should come out to 9, right? So on this test, almost all the questions you can decide if you're right or not by just plugging in at the end.